Hello, Narnach here. Welcome to another episode of ShenZhen I. In this episode, we will be looking at the light up science puzzle, which is going to be for an animated esports sign. So let's start with the why. It begins. I got us an incredible deal with a major esports personality, the Solid Steel Gamer. Her team's contracted with us to make light up signs that actually animate for her fans. As long as we can keep the costs down, they're going to want tons of these to hand out at matches. Looks simple, just a few states. Haha. And then we have it. So this is going to be afterwards. So let's have a look at the designs. Once again, I have multiple designs. I'm going to start with the very first one, rather simple, and it uses only very basic components. The other solutions use a slightly more advanced component that initially you didn't have available for this puzzle, but in the 1.1 patch the developers did add access to all the modules with the recommendation that some of the modules were more advanced than the puzzle required, but would still be useful. So let's dive in. So we have 5 outputs here. Click 0 and click 1, they are simple outputs connected to a display segments over here. So this is the display segment. And we have click 1 and a click 0, and we have a drink 0, 1 and 2. And they're all outputs. And we have a pattern over here that we have to replicate. And let's start with simulating what we're gonna go through. So we have a girl or a woman that's clicking on a mouse and every once in a while drinking. So that's definitely esports, right? So this is the end result. So now we're gonna look at how we did it. The very first solution is very straightforward. So we have 2 outputs here for the click 0, click 1, and they alternate. So what we do is in the first stage we send a signal 100 to indicate that it's on to port 0, which is the click 0. And we send a 0 to port 1 to indicate that it is off. And then we sleep for a second, and then we send the signals in the opposite direction. So we send an off to 1 and we send an on to port 1. And that's how we get an alternating pattern over these 2. It gets more interesting with the drinking, because the pattern is slightly more complex and it also requires 3 output ports. And these modules, they have 2 simple outputs and they have 2 XBus outputs with the yellow dot. You can't send XBus outputs to simple outputs, so we need a second module in order to make it work. This is with just basic components, this is the most straightforward way to do it. So we have this one over here, the top one, which controls the drink 1, the middle signal, which most of the time is off. It just blips on twice with a sleep of 2 in between. So what we do is we send off signal, sleep 6, so that's while nothing is happening, we sleep. Then we send it on, we wait for 2 seconds, and then we send it on again, and in between it's off. So this one just controls the middle one, and then the module underneath here controls drink 0 and drink 2. Because they are both rather simple patterns, that's why I combined them, because they nicely alternate. So we send an on over here to the drink 0, then an off to the other one, then we sleep for 6, then this one pattern is gonna end, so we send a stop over there. Then we sleep for 1 more second, and then this pattern is gonna start. So after we sleep, we send it on, or we send it on, then we sleep 2, then we turn it off, and we sleep for 1 more, and then we cycle back through. So combining it in this way exactly makes things match. And indeed, if we just run it like that, we get a solution that uses 211 power. That's so if you got the profiler here, so if you hold R, you also see what modules were using power most of the time. You see this one is really active, and these are both not doing a lot most of the time. There's a lot of sleeping going on, and as a result, this uses most of the power, and this together uses about 80. and we got some extra verification, and that's it. So this is the very first one, and for a while this was my only solution, and then I came back to it and I had another look, and I figured, well, maybe we can do some multitasking by introducing a slightly more advanced component. And that's this one over here. And if we look at the documentation, boom, this is the DX300 Digital I/O Expander. And it looks a bit more complicated than it is, because what it does is on the left hand side you send a signal. It doesn't really matter where you send it. You send a signal, and it's going to be either a value of 100, or rather, you send a 3-digit signal, and whether you send a 1 or a 0 basically maps to the outputs on the other side. So if you send a 100, then this one is going to be on because you sent a 1, and then these two are going to be off. If you send 111, then this one is going to be on, and this one is also going to be on because the second digit is also a 1. And similarly for this one it works as well. So by sending in one number you can split it and you can control 3 things at the same time. So this is my very first attempt at making a solution for it. So let's hide the manual again and go back to the game. We are using it to the max. So we have one splitter that controls the drinking, and we have one splitter that controls the clicking. And in this case, this one we use as a timer for the right hand side, because it has 6 seconds for one state, then 1 to 1, and then 6 again. So there's a difference in timing between the drinking and the clicking. So I've separated it out so we can set the sleeps more accurately, because otherwise if you want to combine the patterns into one module, you simply don't have enough code space, even if you take one of these larger modules. So that's why they're combined. So over here we send a 001 to the output, and then over here every step it's basically broken in 2. So what we can do here, so we send a signal to the left, and then we take whatever is coming in on the right and we send it out here, and then we sleep. And then we send another signal to the left, and we take another signal from here and we send it to the right. So we have timing over here, and this just feeds off of it. And we are using the fact that the signals over here, once you put a signal on it, it stays on until you change it. So we send a signal of 1 over the analog bus here, and then we sleep for 6 seconds. And for 6 seconds, this signal is just going to be on. So every second, we're going to check what's your signal. We read it and we write it over. And we just keep copying it. And that way, every second we refresh whatever the output is over here, and the signal is always going to be up to date. On the other hand, we send a signal 100 over here to turn the 0 on, and then we do 010 the next frame to turn the other one on. And again, because there is a splitter in between, we're just overriding it, and we don't need to send 0 signals to clear things. And this was a little bit of puzzling to get things in, but eventually it worked. So with the different steps, you can see over here we are slowly just going through, and every second we send out a different signal, and every time we do it. Well, and if you look at it, still does what it does, and power usage is down to 172, down from 211. So this is a clear improvement in power usage. However, I discovered something, or rather, I was curious about something. Do these things hold an internal state? As in, every second, do you have to send them a signal on the X-bus that they consume and otherwise they reset? Or do they retain the original signal, and will they just continue broadcasting? And indeed, that is the case. The signal you sent in last, this module, the DX300, is going to keep repeating it. So that's exactly what I did to rewrite it. The top module is still responsible for the timing, but rather than sending it over the analog channel to the other module to read every second and just write over, we'll just use the X by X bus now, and we only send one signal every 6.121 seconds. So we are gonna spend a lot more time sleeping, and therefore we conserve power. So we're sleeping, and now we send a new signal, and then you see that it changes. And then we're gonna wait for another 2 seconds, and then it's gonna be another one. So this way we don't need the 2 instructions in this block that will read the input and write it. So for however many times this one loops, we only use half as much power as otherwise. And the end result is that we only use 126 power rather than 176. So we save 50 power here, which is quite a bit. So this is the most power efficient one, but we're still using quite some money. Well, quite some, but maybe we can do it cheaper. And of course, when you do things cheaper, you tend to use more power. So on the left hand side, we had a block that was only doing 2 instructions and 2 sleeps, and it wasn't really doing a lot. And we had the splitter in between, but we didn't really need the splitter. So I went back to basics here and just directly connected this module back using the very same code that we used in the very first solution in order to simply power this by hand and reset both of the modules every second. So we use a bit more power, but the end result is that we did manage to cut out a splitter, and now we're down to 7. And as such, the solution still works, and we're back to 172. And this scores us in the top segment over here. So we now have 2 different solutions that each score in the top segment of their respective class. The histogram suggests that there are solutions that are even more efficient. There should be one that uses even less power, because there is another small bar here. So if you manage to find out what it is, leave a comment, share it with your fellow players. And similarly, if you manage to get it down to 5, if you get it down to 5 or 6 yen, again, leave a comment to share how you did it. Because I tried to reason it out and I couldn't find anything. These were the best solutions I could come up with. So now we're gonna go back, and of course our colleague here, haha, the end result looks great. I love the way it looks like the solid steel gamer is really clicking the mouse button and drinking her soda. This is going to be huge. So, and with that, I'm gonna thank you very much for watching yet another episode of ShenZhen I. Next episode, we're gonna have a look at the rubbish audio thing. But that's gonna be next one. So for now, thank you for watching, and I'll see you again next time. Bye bye.